This conference will now be recorded.
All right, we'll give it another minute or two as some people are joining, and then we'll get going. All right, welcome to our Vitrek session on test and measurement equipment for the automotive industry. My name is Don Milstein. I'm president of Vitrek. We'll be joined by Chad Clark, our VP of Sales and Marketing, and he'll be presenting. So, Chad, if you're there, why don't you say hello to everyone?
Hey guys, thanks for tuning in today.
All right, great. So I want to just give a kind of a quick introduction and then turn it over to Chad, but there's both our contact information, and everyone will receive this presentation after this. So feel free to take notes, but you will receive the whole presentation. Go to the next slide.
Yep.
So what we'll do is throughout this presentation, we'll periodically stop. So if you could, put your phones on mute during this call, that's great. And there's a chat feature at any time. Feel free to go in there, ask the chat. We have people monitoring it. We'll answer your questions. When we get to these break points, we'll respond to those chats verbally also, so everyone can hear. And at that time, we'll have you an opportunity to unmute your phones and ask any questions. So chat throughout, and we'll unmute as we go. So just a quick intro if you're not familiar with Vitrek. In the industry for over 30 years, test and measurement, really focused on high voltage is kind of our claim to fame. We're headquartered in San Diego, California. All of our engineering, manufacturing, sales support is all done there. So we're American made and fully supported out of that office. But we do take an international view, right? So we're obviously throughout the US we sell. Internationally, we have over 30 distributors on the ground in various countries and then sell to the rest of the world throughout. So definitely look at as a international company, both from product wise, from industry standard wise, right? We track it all. We'll touch on our products in a second, but HIPOT testers is one of the big areas, cable test systems, power analyzers, and so on. So we'll look through that. Good. Our facility is ISO 17025 approved for calibration, so everything gets calibrated at our facilities, and we also can provide that as a service thereafter, or go to your local calibration lab. So we give you that opportunity, but it just shows the credibility of our facility and the quality of it to make sure we maintain that ISO certification. When you think about our customers, now obviously today we're going to focus on the automotive industry, but truly we work in all areas, right? The LEDs, the lighting, the aerospace industries, And during COVID, we were very proud that, we got the call from the governor, said we had to shut it down, but right away we went from there to going into the office because our customers responded to us saying, hey, we need you to come in. We need you to, we're critical infrastructure. We're in aerospace. We're in the defense industry. We're in the medical industry. And our team really stepped up and who stayed active throughout this time period. Very proud of that. Go to the next slide. From our customer standpoint, a lot of what we do is on consumer products, right? Refrigerators, toasters, those kind of things, computers coming down the line, all your big electrical infrastructures on the commercial industrial side and the automotive industry and medical. And you see companies like Siemens and Eaton there. We do a lot on the green and sustainability industry, and electric vehicles is a big area for us, both charging stations, the cars themselves, the cables that are involved, a lot on the solar industry and lighting industry, battery industry. So fits well with what we're going to speak about today. And then in the lab space, when we're talking about labs, we're talking about third-party calibration labs, as well as some of your big certification houses like UL and CSA, and your government laboratories like Lawrence Livermore and some of the military, and we have many countries using our products as their standards. When you talk about the products, and Chad will go into this, the HIPOT tester is probably we're best known for. Pretty simple, right? Make sure you're testing for electrical leakage, make sure we're not shocking everybody every time a refrigerator or toaster comes down the line or electric cable. We're doing that test. We can do it in multi points at the same time. Power analyzers, obviously, is a key market for us, looking at the energy consumption at a high level, both the power used, the efficiency of the power, when it's in standby, how much is it using? High voltage meters is another key market for us, truly industry leader in that. Very high precision meter to the point that is used, like I said, in various countries as their base standard for their labs. A fairly newer product for us is the digital DC load test instrument, for power supplies and batteries and such, looking at voltage, current, power, and resistance. And with that, just want to kind of take a second and see if there's any questions. And if not, I'll gladly turn it over to Chad Clark, our Vice President of Sales and Marketing out of San Diego, to go through this presentation.
All right, Don, thank you for the intro.
Yep.
I hope everyone can hear me. And we're going to dive into this thing. So got about maybe 25, 30 minutes worth of stuff we're going to review. We have a fairly small group today, so I encourage you guys to, chime in. Like I said, get in that chat, ask a question, or just wait till we get to one of the question slides and definitely ask a question, even if it's a little bit on the fringe of what we're covering today. I think due to this group size, we can definitely accommodate it. So let's see what happens here. So we have a couple different plays in the automotive industry to support those customers, those manufacturers, going back into some more of the traditional ways things are manufactured, and we have some solutions that really play well into the power conversion, energy storage, and transfer side of it. So we're uniquely positioned right now to actually have quite a few different solutions. And traditionally, one of the best solutions that we offered, and this is actually even getting better for us now as we're seeing voltages increase on these harnesses, is testing harnesses, testing printed circuit boards, typically of the flexible variety. Everything within a car that has electricity flowing on it is, in general, supposed to either be isolated or connected. There are 20, if not more, harnesses throughout a car. So many things going on these days. It's very complicated, and more of that is controlled by microprocessors. So it's important that things are manufactured correctly the first time. We're also at a point where consumers have very low tolerances for call it warranties, recalls, things like that. People tend to be very sensitive these days. If they have to get their car repaired one time in the first 3 years of ownership, that's just unacceptable. So using our equipment, you can test these harnesses and these electrical components that tend to be the highest rate of failures in cars. We're going to be able to identify miswiring, mismanufacturing, you know, if anything in the harness was pinched or damaged when it was installed. You could have something that's perfect coming from your supplier, tests out on the bench perfectly. You install that thing within a vehicle. Now all of a sudden, you know, you have breakdown to chassis. Or you drive the car 30, 50, 100,000 miles, and the insulation wore through in an area where it wasn't secured properly, and now you have an issue. These are kind of the things that we're going to be able to discover. So, like I said, there's two sides of this. There's things that are supposed to be connected and things that are not supposed to be connected. So the way that we identify things that are not supposed to touch and be isolated from one another is going to be with an insulation resistance test, or a DC HIPOT test, typically in this voltage. And it's a very simple test. You're going to have two conductors with an insulator in between them. One of those conductors could be the chassis of the vehicle. One of them is going to be, let's keep it simple, like your 12-volt positive terminal coming off the car. So you're going to put high voltage on that. You're going to ramp up from 0 to 1,000 volts, whatever it may be. You're going to hold that voltage for a period of time, and then you're going to discharge. We're going to monitor that and make sure that there isn't excessive current flowing from that conductor through the insulation to the chassis, another conductor, whatever it may be. And that's really the basis for all insulation testing across the world, whether it's done in a fancy automated system or with a little handheld meter. All right, so the opposite is going to be ground bond and continuity testing. This is where you're going to have things that are that should be connected and verify that they are connected. And we're going to do that either at a very low source current, potentially with a 4-wire Kelvin measurement, to make sure that we have really low contact resistance. If you're trying to you know, push a lot of current, a lot of power through a given cable, and you have a poor connection with high resistance, that's going to build up heat, and that's going to be unsafe. Or you could lose performance in a situation where you're basically not getting some of that power where it's supposed to go. That's going to translate into you know, lower efficiency levels, and things just get worse over time. When you make a connection, it's typically going to be the best it ever is going to be on day one. Over time, it's only going to get worse. At the higher current levels, like up to 40 amps with a 952, for example, we're going to be able to actually stress that conductor, stress that connection, and see if we can get some heat to build up within that connection. And as that heat increases, the resistance will increase and hopefully run away and reach the point of failure. So those are the two methods that you're going to see you know, throughout this for measuring isolation and connections. If you're not familiar with the 4-wire Kelvin measurement, you source current across a DOT, and then you measure the voltage drop across it, and we convert that over into ohms, because most people are looking for a result in ohms, although some specify a voltage drop in some of the standards out there. All right, so the equipment that we do this with is going to be one of our HIPOT testers. We have two main varieties, and this here is the V7X series. It is good for about a microamp of leakage current. We're going to output up to 5 kV. It's a very easy to use tester. It's on production lines all over the world, actually. Color touchscreen, nice GUI on that thing. You're able to see the test setup that you have before you run it. It's rack mountable, manufactured here, more importantly, supported here in San Diego. You can talk to a real engineer in a time zone that's within a couple hours of you. So great solution there. If you are trying to go higher in voltage, trying to measure lower leakage current levels than a microamp, 950 is going to probably be the best solution for you. That's a little bit more power, a little more voltage also. Overall, they're very similar. They're going to perform the same types of tests. This is just going to give you a little bit more accuracy on the bottom and a little more power on top. All right, and this is kind of where we bring them together into our automated solution for testing these harnesses, cables, printed circuit boards, whatever it may be. So usually we'll bring a 950 in, pair it up with the 964, which you can see in the photos on the right, and bring in our Quick Test Enterprise software, sometimes the Quick Test Pro software, and combine this all together into a solution. So we're going to look at the schematic of your device. We're going to configure a 964 switch to work for that schematic and set up the sequence so that we're going to turn on relays and turn them off every single test. Effectively, what we're going to do is we're going to sweep through the whole thing. We're going to make sure that things are connected, things that are isolated are isolated. We can do that up to 15 kV DC. Might sound like a lot, but some of these buses are getting in excess of 1,000 volts. I've seen plenty of people testing at the 5,000–6,000 volt level, which was, kind of unheard of in the industry 10 years ago. And I see no reason why we couldn't be up to 15 kV here in a few years on some standard tests. We're going to be able to switch currents up to, I should say carry currents up to 70 amps. Normally we try not to switch the relays when they're energized, just because that lowers their life. And that's all controlled automatically. We can daisy chain up to 16 of these chassis. It's going to give us hundreds of unique test points. And most importantly, we can control each relay individually. Some of the standard cable testers out there, which are going to be limited to around 1,000 volts, maybe 1,500 volts, you don't have the ability to control each relay. So if you have a complicated device that you're testing, sometimes you're going to have to bring that into a second station and test that by hand. All right, so within these 964 chassis, there's a variety of cards that can go in them, and that's going to depend on your test voltage, number of test points, maybe the future. Maybe right now you're happy with 3 kV and you would go with the LV3 card, but you know that next month, next year, next deal that you're working on might be at 5 kV. So maybe you're better off going with a 7 kV rated card from the beginning. So it's typically going to be outfitted with a variety of relays that are going to carry high current, isolate high voltage, or we have some relays that actually do both, and we'll talk about those a little bit later. All right, so you have this 964, it's hooked up to your HIPOT tester, and basically what it does is it takes the ability to have one high voltage output and one return point on your high voltage tester, your HIPOT tester, to have hundreds. Typically you're going to run a high voltage and a return lead to each point to run this whole test. Both the 5X and the V7X can completely control these in a standalone situation, so you don't have to use the software. Most of our customers are using the software, and what it lets them do is see a graphical representation. You can see there at the bottom, you can monitor the voltage, the actual output, and you can look back at the history and see what the voltage was, what your ramp times were. You can see where your limits are set, and you can see what your isolation is. Here it's in gigohms. All of this can be linked to a serial number of your DUT, and you can save or print a test report. It really gives you the opportunity to collect data that you can analyze over time, or simply, 5 years from now, someone says, hey, we need proof that you tested this harness because it caught on fire and we think it was, not manufactured properly. And you can pull this up and go, here it is. We tested it. It was 2,057 gigohms. So take your lawsuit somewhere else. So Quick Test Enterprise is a solution that works for a lot of different manufacturers. And one of the areas where we're able to be kind of flexible as you go into this, the general settings and the global settings throughout the software. This is where you can personalize it for the way that a company is required to test or likes to test. You can do things like who's going to start it. Is it going to start from the DIO? Is it going to start from a click of the mouse? Whether you want to set maximum and minimum loads. If you had a failure, do you want to continue or do you want to stop? Some people are not interested in remanufacturing anything, so they're just going to, if something fails, they're basically just going to trash that device and start fresh. Other people are going to rework it, so they're going to want to continue on a failure. Obviously, you can save it, auto save if it fails, if it passes, whether you want to require someone to enter a serial number. Some people are printing these reports. Oftentimes, they will only print them on failure, send those out to rework, and that way you know that test step 57 failed, and that test step 57 is connected to conductor 23, and you have a really good place to start looking, you know, at what you need to fix. All right, so this is probably where most customers have the biggest question here. Okay, this is great. So I have a tester, I can test all these points, and I have a cable, and how do I link these together? And this is where you can graphically go in here and represent every relay within your 964 and set up your switch steps and your switch step sequences. So basically what you're going to do here is you're going to check the box of the corresponding relay. So in this situation, you know, we have 8 banks within the 964. Let's pretend we have 64 relays fitted. And in this test step, which is test step 1, which is a switch step, we're going to be turning on relay 1 and relay 33. There's a block diagram that's going to show you what those are connected to. Normally, relay 1 is going to be on the return bank. Relay 33 is going to be on the high voltage bank. So what we're going to be doing here is we're going to test isolation from whatever's connected to terminal 33, usually, to terminal 1. We're following that up with a 3000 volt test, and then we do another switch step. And you can see that whole sequence summary on the right side. If this was live, and we can show you guys a live demo of Quick Test Enterprise at any time, we'd be able to scroll through and see exactly what steps are making up our sequence. All right, so you've written these test sequences and you've ran them, and this is where you can kind of go into the back end depending on what your user rights are. You can look and see what dates tests were ran, the time, the serial number of the device that ran them. We have, you know, in the back end, you can look at your different users and see, why does Joe have a higher pass rate than Tony? You can look at all kinds of different things, including you can look at the days and batches and things like that and figure out if there's reasons why you have lower quality parts by certain individuals based on serial numbers and all kinds of stuff. Plenty of opportunity to find out data if you're into crunching it on the back end. All right, so normally once you have this whole system in place, operator safety is very important. There's a bunch of technology built into the HIPOT testers that are going to limit current, quickly detect breakdowns and discharge, but I always recommend, if you can, stuff your whole DUT within one of these enclosures. There's basically a feed through in the back. You're going to have your fixtures, your mating connectors in there. Put it in there, close the lid. The interlock will make sure that high voltage isn't applied to your DUT with that lid open. Even if you started a test and opened the lid, it would abort. So it's probably the easiest way to keep your operators safe and their hands off of the device while you're testing it. So we'll talk about a real life application here, and this is where we were able to utilize both our high voltage isolation tests capability and our ability to measure low resistance, and that's with EV charging cables. So you have a cable that's going to, in a connector that's going to be subjected to harsh environmental conditions, UV, dirt, water, road grime, things like that over years and years. So you need to have a connector that is has very, very low contact resistance. When you're charging these cars, you're trying to put in tremendous amounts of energy as fast as possible. You have 3 hours to put in, I don't know how many joules it would be, I could do the math, but so it's very important to have very low contact resistance. At the same time, you want to have isolation in the 5,000 volt range. We're able to develop a 964 that's able to do both. So we can measure contact resistance that's going to be in the micro ohms of resistance, and also test that at 5,000 volts and do it in an automated situation. All of these connectors are going to have temperature sensing pins and things like that. So it's never a simple plus and minus DC anymore. It's always going to be 3, 4, 5 conductors at minimum on these cables. If anyone has any questions about it, I can show you guys the diagrams of the 964s that we've used and the relays that we use to test a harness or a cable or a connector like this. Does anyone have any questions here? We're going to kind of switch over from the power, I'm sorry, not the power, but the high voltage and isolation side over to more what we can do from a power conversion side. All right, let's do it. So another key component that I should say, a key piece of equipment that we have is going to be our power analyzer. This is designed in the US, made in the US, and there's 3 different versions of mainframe chassis for this. It's the PA900, and what it does very well is measures power, high power, up to 32 amps directly. We can go up to 3,000 volts directly. So we're really in a sweet spot to measure high power applications with fast transients, and graphically show all of this on a screen, or embed this whole thing into a embedded solution where we're doing more analysis, data keeping, data collection. All right, so each unit is going to have up to 4 cards in it. We can link these chassis together to give you multiple power measurements. For example, if you wanted to do a 3-phase in to 3-phase out converter, you could use 2 chassis, you could synchronize those together, and you could look at the power transfer across that converter. We have cards that are designed for high bandwidth, high current, low current, and that's really where we just have to get into your application and find out what the right configuration is for you. In addition to that, if you're going above what we can measure in the internal shunts, we can go to an external CT. We can do the same thing on the voltage side. If you happen to be going over 3,000 volts, we can use a PT to ratio that voltage down to something that we can measure. We publish the full command set. Our interfaces are, Ethernet, USB, serial with the option for GPID. So there's nothing stopping you from using this product in a fully embedded solution where you don't even need front panel control at all. All right, so when you're looking at, block diagram of a car, whether it's a hybrid or an EV vehicle, there is a tremendous amount of power conversion going on, and things that are going to convert that power, use some of that power, from the heater to the stereo, air conditioner, windows, you name it. At some point during the development process, you really need to understand where all of your power losses are, where you can gain efficiency, where you can't. And anywhere on this diagram that you see a line, specifically a red line or blue or green line, is an opportunity to hook up one of our power analyzers and measure the power on each side, measure the transfer, and you can bring this all back to one common system and really get an idea of where you're efficient, where you're inefficient, and that's going to show you where you can improve your products to increase range and things like that, or ultimately power output. All right, so basically the way that you connect it, you're going to have two VPAs within the power analyzer, which is a synchronous measurement across those channels, and that could be anywhere from one conductor, if it was a simple DC measurement, to 4 channels within that synchronous VPA. You're going to connect that to both sides of whatever is the input and the output. Sometimes it's going to be 3 channels on one side, 1 on the other. It really just depends. And the power analyzer is going to give you a synchronized live power reading that we can convert into an efficiency number, and you can see if that is 99, 5% efficient. And obviously that efficiency is going to vary across the range of the converter. At very low power levels, they're going to be horribly inefficient. Then they're going to have a sweet spot, and then they'll probably become less efficient on the top end. So you could take that through its cycle, and you could map or plot the efficiency of that across different power levels. Just to give you an idea of our accuracy, I mean, we're talking about really, really high levels of precision here. 0.03, 0.05% of readings. This is power, total power. A lot of the manufacturers out there, you'll see them specify voltage accuracy and current accuracy. We just give it to you up front, and typically our total power accuracy is going to be as good as other manufacturers' voltage or current accuracy. You can see the voltage, our RMS voltages here, the kind of bandwidth that we can handle, and our current. And this is for the PA920, which is our newest power analyzer. Does anyone have any questions? If you don't, or if you have any questions that are complicated, or you want to email over to me, please do that. Sales@vitrek.com is probably the best email address to reach out to us at. We'll be more than happy to support you guys with any questions you have. We will email this out to you. Probably going to come from Susie Abbott, and we'll have this posted on our website and online if you guys want to reference back to it. So if there's no questions, I'm going to go ahead and sign off here. I hope you guys have a great day, and everyone take care. Thanks.